Hi everyone, welcome back to my next lecture. Today we are going to talk about parallel lines and transversal. Transversal is quite interesting and many problems can be solved using transversals. First, let's understand what a parallel line is and then actually talk about transversals and other things. So before we understand what a transversal is, it is important for us to understand what a parallel lines is. Parallel lines, as you know, like I think you might have heard multiple times, probably might have come across at multiple scenarios, what a parallel line is. The parallel line in a simplistic sense is both lines never intersect and any point on the line, right? You take any point A, any point X, Y, Z. The distance between these 2 points remains the same. Wherever you measure, like now you figure out any 2 points on these lines, right? I think you start here and then you mark the 2 points. These 2 points are equidistant here. These 2 points are equidistant here as well. So that is in short a parallel line where like most of the distances between the 2 points on both lines remain the same, even if you infinitely extend it. It's quite simple, isn't it? Can you think of some of the real life scenario parallel lines? The obvious thing that comes is railway track. Railway track, right? Okay, I messed up. It's like, I think, let me write it more legibly. Railway track, right? So a lot of people say tracks never intersect, never do, but it happens that while tracks have done, like you can see that in between, like I think some of the tracks, they don't intersect. But for all practical purposes, we take railway lines as one of the things where they never intersect. All right. Now that we understood what a parallel line is, let me actually talk about something called transversal. Transversal is quite interesting concept. Let's take two parallel lines, A and B, the arrow line A and B. Line C, which intersect both parallel lines, is called transversal. In this case, like transversal has some interesting properties. I would also explain, like, I think these things in a simpler terms. Let me tell you, transversal is a line which cuts two parallel lines, right? Um, so what happens is when transversal cuts the parallel lines, it creates some angle. In the picture, if you can see here, it creates angle 1, angle 2, angle 3, angle 4, angle 5, angle 6, and angle 7, and angle 8, right? I tried to mark like some of these angles in the same color so that you guys will be able to understand this, and we'll get into the details of it, like why these angles are same and why they have to be same, right? First, let's talk about corresponding angles. Transversal C cuts line A and line B. So if you see only angle 1, let's take angle 1 and angle 5. These angles are called corresponding angles. Angle 2 and angle 6 are also corresponding angles, right? So angle 4 and angle 8 also, like I think they also follow corresponding angle. I think let's see, like I think there are external corresponding angles and internal corresponding angles kind of thing. So let's talk about angle 1 and angle 5. Why they have to be equal? We've been told that transversal cuts two parallel lines and angle 1 is always equal to angle 5, right? Why these two angles have to be equal? They have to be equal because, any guesses? Assume that like parallel lines never intersect. That's what you've been told. But assume that there is some kind of a distant wrap, like Albert Einstein has told that there is time wrap, distant wrap, and it's a completely different concept. But assume that A and B, like the distance between them is 0. So what happens if you take line B and superimpose on line A? What you see is that, like I think as you start moving this line closer to line A, you see that angle 1 and 5 coincide. And typically, like in triangles and others, this concept of overlapping things, where like I think essentially there is no delta or no extra thing that shows up, is called congruence kind of a property. But we try to do, this is not called congruence, but try to do the similar thing. Take line B, forget that there is distance between A and B, and then superimpose on top of line A. So what happens is that you see that angle 1 is equal to angle 5. And this is the precise reason why I think corresponding angles tend to be exactly the same. What are the corresponding angles here? Angle 1, angle 5, angle 4, angle 8, angle 3, angle 7, angle 2, and angle 6. And this is one of the reasons why what you call corresponding angles always tend to be equal. Whenever you got it out, like what you can do is you can cut this what you call angle line B and try to superimpose on line A, and then it will be clear to you that the angles exactly are same. Why don't you take an exercise where you write all these things on a paper, um, maybe semi-translucent paper, like I think, and then try to mark these things using a marker, cut somewhere in between A and B, and try to superimpose that and see if the corresponding angles are equal. All right, let's talk about alternate angles here now. So list down the alternate angles. What are the interior alternate angles? Angle 3, angle 5, angle 4, angle 6. Now, if you see the interior alternate angles, 4 and 6 are equal and 3 and 5 are equal in the same picture. Why do you think the alternate angles are equal? So one way of actually representing this is, as I told you, you have to cut the picture into half, right? And then superimpose on top of it. So what you have seen is that, like earlier, we have studied something called, right, vertically opposite angles are same. If two lines intersect, whether it's transversal or not, vertically opposite angles are always equal. So when you superimpose B on top of A, what happens? 1 and 5 will be here, 6 will be here, and 3, in place of 3, there will be 7 that will be coming here. In place of 4, there will be 8 things coming here. So the easiest way to understand this is why alternate interior angles are equal. It's because angle 4 is equal to angle 6. Why? Because when you cut and actually superimpose, you can easily see that they become vertically opposite angle. So that is the reason why I think alternate interior angles are always equal. And it's not a rocket science. So the easiest way to actually remember this is cut in the center and probably superimpose that. Then you'll know like all the corresponding angles, all the alternate angles, and everything you could actually recollect. Like you can easily get it. 4 is equal to 2 is equal to 6. 4 equal to 6. 3 is equal to 5. 1 is equal to 1 is equal to 5 because it's corresponding angle. 2 equal to 6 is both corresponding angles. External corresponding angles, 3 equal to 7, 4 equal to 8. So you don't have to remember anything, right? Largely, that's how it is. Now they have one more interesting property. Sum of co-interior angles is equal to 180. So this is also something that you don't really have to remember. 4 plus 5 is equal to 180, right? 3 plus 6 is equal to 180. See, people tend to tell you, like, I think, a lot of formulas and a lot of things, unless you understand the reason why I think it is like that, you wouldn't understand. And it becomes too overwhelming to understand and remember so many things. Now, with the simple thing that I've told you, where you cut the transversal into half, parallel lines, and superimpose, you literally don't have to remember anything. Largely, I think, alternate angles, interior angles, and this is covered. Now, there's also interesting property that people say that like one same side of the transversal, if we add both of them, which is 4 plus 5 is 180. How come 4 plus 5 is 180? Because it is not something again same thing, right? I think we learned something in the last video called linear pair, right? It is nothing but a linear pair. Suppose if you actually superimpose again back there, because 1 is equal to 5. So what happens is 1 plus 4 is 180 because it is linear pair. In case of 1, 5 is also same. So what happens? So what people are saying, 1 plus 4 is equal to 180. You don't really have to remember that because this is a linear pair because transversal is also a straight line. The linear pair rules actually apply to that. In place of 1, I think they added 5, which you can do because they are corresponding angles. So 5 plus 4 has to be 180, 3 plus 6 has to be 180. So don't look at like I think understanding transversal as multiple formulas. Corresponding angles are equal, vertically opposite angles are equal, that equal, alternate angles are equal. You don't really have to understand all of those things. What you need to understand is only two things, right? One is vertically opposite angles are equal, and you also need to understand what is a linear pair, which you have done in the previous classes. So that's it largely about transversals. we're going to see, because transversal is a little tricky concept. I'm going to solve like 1 or 2 problems in transversal in next videos. But hope you understood the concept behind corresponding angles, alternate angles, and linear pair, and which is the reason why I think co-interior angles on same side of transversal adds up to 180 degrees. Hope you like this lecture on transversals. I think I'll keep a lot of things coming here, and I love solving problems on transversals, so I'm going to solve 1 or 2 problems for you. Maybe I'll pick a little bit hard problems in NCERT textbook. Thank you.